All right, all right. Well, today I'm doing the same thing I did yesterday. I have been looking into some of the example scripts from FreeCAD, and I realized that there's probably a slightly better way to go about what I'm trying to do. So I rewrote a few of the emitters, and I'm just in the process of figuring out if those rewrites will actually do what I need. And that's the whole deal. So let me just check that things are good to go here. Mm-hmm. Mm-hmm. Okay, so we've got some FreeCAD experimentation going on, and we'll keep that ball rolling. So what I don't know is if the rewrites will actually load properly. So let's try that. FreeCAD CLJ seems to be. So let's define some kind of shape to test. What I want to do yeah, let's do a square. Okay, it does have something. Oh, there will be one problem, but actually we'll sort that out later. Let's not worry too much about it at the moment. Okay, so let's make a little more involved than just that. Just a square. Excuse me. What I want to do is make it a square of 20 by 20, and I want to translate it 0, actually 10 10 0, yeah, and then I want to extrude linear height 50. Let's see if this works. Okay, it emits code, which is good. All right, let's see what's up with this. So this should clear the dock. Seems to work. Now the only thing I have to do is part.show this extrude 18790, and it seems to have worked, which is very exciting. That is really good news, actually. Let me also okay, so this is promising. We're heading in the right direction with this stuff. That's good. Okay. So what I need to do is make a little function that actually creates the right call to show the object in from the post. Jeez, excuse me, sorry. So here, right, the post amble has a doc.recompute, which what I actually want to do is part.show and then the name here. Actually, we should do that. FCS gen. Yeah, that's the name of the thing, but we need here the name of the last name here, which I think I can actually do. So if I do define that and then you pass name in, then all it is string this part over the rest of this. Ooh, that doesn't read very well. Let's change it to this, I guess. Name, like that. Let's just change this a bit. These things, leave that out for now. Those seem okay. That's a good start. I can deal with those things. Yeah. And that means now write FCS should take this and return, or it should pass in a name which has to be calculated from something. So if I do this, let block string be apply right expression to block. Strings, block strings is this, and then the name is get name from last of block strings. Should be good. Let's see if that's true. Oops, so it didn't work there. Which, I mean, okay, that's not too surprising. Let's change this up just a bit and let's do block strings. See what that returns. right, I need to see what this looks like without that. Right, so we've got actually just right. I need to switch it up. Oh, I know. Block string is like that. Here, what I want to do is change this up a little bit. So let's do block string is threaded through string slash split lines. Split dash lines. Split lines last get name. And then let's see if it returns a name when I do that. It does. Okay. That's promising. So it should let me do. Ooh, block strings doesn't exist. Of course, it's block string. Hey, there's something. All right, let's copy that with the print line situation. Make it a little easier. There we go. Let's try that again. Oh, paste. No. Okay. Multiple statements found while compiling a single statement. Well, there's one thing going wrong up here. This needs a comma. If I try to run that now, let's see. Oh, here as well. That needs a new line. The comma's good. I need a new line in there. And that's easy enough to fix with this here. Oops. Let's try that. Promising. Let's try it. Oh, it's lowercase. Oh, seriously? Well, let's see if it'll work. If I lowercase that. Okay. Nearly there. There we go. Let's try it one more time, huh? Yes. Okay. It's working. That's nice. That's good. That's great. All right, now let's try a more complicated one. Let's do a revolve. So let's def B as thread square translate that. Should be centered here. Let's just move it 50 in X. Yeah, that should be okay. And then we do extrude revolve. That should. Oh, extrude rotate. I'd need to change that name for sure. It's very confusing to me. All right, let's see. Let's try that. Right. Okay. Not sure why there's a nil there, but I can deal with that later. Oh, wait a second. The extrude rotate is not doing anything. That should be fine, but let me just. Okay, so the nil is related to the nil is an empty map. It's an empty property map, which I probably should change just to be handled just a little nicer. So that'll be in here. Extrude rotate here. I think the way to do this is merge blank map with options. So if I merge blank map with nil, it does return a blank map. If I merge a map that has properties in it with nil, it's good. Okay. That's what I'm looking for. So that should. Let's load the file. Source FreeCAD clj/model.cljc. Hopefully that reflects the difference there, but it shouldn't really matter, honestly. Let's define B now without the extrusion angle. Well, now I've just confused myself. If ops, otherwise, oops. What? Well, I'll figure that out in a minute. Before then, I'll just do this. So it's something. Wait a second. Let's do. What am I trying to do here? Extrude rotate. Oops. Okay. So now B. All right, let's go with that for now. That's fine enough for me. Okay, right, so let's write FCS of B. Print line, write FCS of B. Let's see if this works. It does not. Perfect. Okay. Function takes 3 arguments, 2 given. Which function went wrong? That's the question I've got. The Revolve did. So okay, so rotate is missing an angle here. If I were to do this, if I set copy this, paste this here, and I put in that, it worked. Then if I do this part.show, it works. Okay, so we're most of the way there. The only thing I need to do is fix the rotate function, which is over here. Which is over here. And I need to add into this function A. Oh, what did I mess something up here? Is it so inside extrude rotate, oh, this can actually stay down here. Extrude there we go. Extrude rotate. If I have a look at here, this rotate is missing this has to be here, and the angle has to be 90 degrees, like that. and then you close the function. So that should fix that actually. So let's try it. Let's give this, oh, that's the wrong one. Let's give this one another go. Here, doc recompute, copy that. If I paste this in here, it should clear everything and then actually put exactly the same result back in, and indeed it does. And we can sanity check that by redefining B for a moment. Let's translate it a little less so it's a smaller ring. And let's actually, while we're at it, let's make this 270. Let's see if those changes are visible. Yeah, they are. Excuse me. Oh, that's exciting. I'm very happy with that so far. Let's have a little peek at what I can start to do next. Yeah? Yeah. So let's assume for the time being that these are all working. They might not be, but let's assume that they are. Let's work on the next set of things. And those things are difference. Excuse me. Oh. Union and intersection. Oh, before I do that, I would like to let's def C as something again. So here what I'd like to do is define C as some rotation things. So those are going to be like well, let's do the cylinder thing. Cylinder, the radius is, let's say, 20 and the height is 100. Let's do that just as is. It's an extremely simple part. It should work no problem. It's looking good. Oh, let's also do view. Okay, there's the center. We're good. So the center here is right where I want it. It's centered in the cylinder there. So now if I redefine C to also include a translate in the Z direction, I want to do 0050 as the Z translation. And the reason for that is just to double check that things actually are translating properly. So that should put the bottom face at the origin, which it does. That's good. So using that shape, what I want to do, or using variations on that shape, I want to double check that my new rotation stuff is actually working the way I want it to. So to do that, let's rotate 4500 like this. Ah, okay. So we've got stuff that's not working, which is not great, of course, but we can go from there. So let's have a peek at what's happening here. So in fact, what I should try before I go into that is do this. Okay, so we've got one situation working and not the other, and that's okay. We can figure all that out. So here, that's exactly what I wanted. It's rotating about the global origin. That's a good sign. Now let's change this. Translate it up 50. We'll go like this. Copy. So here we have, I do believe, a problem. Wait a second. Sorry. I have to check. I have to check that I... Yeah, it did. Yeah, we've got to rotate along X. Translate. Yeah, it's supposed to work. So what's going wrong here? Let's see. Right, so the cylinder is made and translated automatically to its center point. I've got a bunch of redundancy stuff in here. Okay, so I have to fix a few things here. Although this line does technically reflect what I want it to. So for example, the cylinder name, if we ignore the second equals, that's fine. You make a cylinder, you translate it to its center, then I manually translated it up again. Then it should be rotated. Let me try something with just C. Let's do right expression. There's a few things going wrong here, I think. But before I delve too deep there, what I can check is the logic of this part on its own. So this line I would have expected to work. So let's do this. Let's paste it in there. What did I just paste in there? It did work. So yeah, so the logic of it does work. I just am completely doubling up a lot of declarations and creating unnecessary mess in the structure here. So that needs to be fixed for sure. So how do I do that? Okay, well, let's start simple, right? Let's do a write expression of translate 0050 of cylinder 2100. Okay, so let's have a quick peek at what this all puts in there, right? Let's make it just slightly easier to read. Okay, so these are the lines it produces. Okay. So what's happening here is it's plunking in the string that is the cylinder part of this evaluated as is. That's good. That's what I want. Then it's doing something wrong with the rest of this. So what I want to do instead is this. I want to do right, so it's plunking the object in there directly, which already has a name, a variable name here, assigned to it. The name this is just incorrect. Yeah. This is not totally right, but that's okay. It's actually pretty easy to fix. So I can make name. I could do this. I could do object name is that, which is exactly what I want. Name is gensim. Translate. Yeah, that I don't know that this is ultimately the right way to do it, but it's not too bad. I mean, alternatively, I could actually just make it even simpler. Let's keep going with it this way. So the object, plunk it in there. Yeah, let's start with that. New name equals not the object anymore, right? It's its own thing. So what it actually equals is object name, like that, dot translate. Yeah. So that should still work because you're defining the part and translating it right away. Then the new cylinder immediately has that attached to it. I don't know if I like that though, so because what do I do now if I run get name on this whole result? It gets the first name that occurs, which is not. Okay, I'm gonna try it. I'm gonna try it this way. What I want to do instead is actually super easy. You write the expression, then you just append. You don't need a name. You don't need the object name. You just do object dot translate like this. So now it's just a single cylinder. Translate it again. That will work. Is it the best way to do it? Probably not. Is it the way I'm doing it for now? Absolutely. Right, so using that same logic, again, I can just do object equals the stringing together of the object and the rotate result like this. Which now is hard to read, to be honest. Okay, so you do a string object dot rotate. I don't like it. Oop. Okay, let's give it a shot. Okay, so C, shape C, has a translate. It's a cylinder, then you translate it, then you rotate it. So if I print line, write expression C. Oh, that's, sorry, not actually what I wanted. I wanted to do write FCS. Now I want to see if this works. Let's see. So far, so good. That's promising. Next thing, I want to see if this convoluted approach well, let's def D as the result of taking C, the shape C, and then doing a rotate -90 on let's see, it's 45 along. Well, let's just do it on X like this. Okay, no reason not to, huh? And then let's do this. Should give us a different shape. It should give us this shape the other way. It doesn't. So what's happening there? What? This should work, shouldn't it? Sorry, let me just mess around with this. Okay. Oh, it did. Wait, did it work? Yeah. I was a little, I'm just confused, that's all. I just want to see if this, oops. I want to see if this works. Part.show. Cylinder 19164. Okay, so things are working. I'm just, the copy and paste approach is getting a little messy. I think that's what's going on here. All right, so that's fine enough for that. What I need to do now is define, let's redefine C again. What I want to do here is make this work, which it doesn't yet. So if I write expression of C, you've got a problem here. So that is coming from a few places, I think. So first off, C, it's got this rotate C, whereas D, it has this rotate V initially here. So what I need to do instead is fix that. And to do that, I can have a quick look at how this is going here. So what I'm wondering is why this wouldn't work. Right, so first off, let's have a quick look at so there's it must be something wrong with this formation. Which does honestly surprise me a little bit. Right, because if I were to do this as just this, if I were to get rid of this, this should work, right? Yeah, it does. And the reason the reason it won't work. Oh. Oh. Of course. Rotate form returns a string. So what I need to do instead is convert it. I need to do it this way. I would need to instead convert it like this. If I rotate it's actually like this. I have to do the same thing. It's equivalent, but before that I have to change. I have to let forms be the result of map rotate, or sorry, map thread last the form rotate Z001 yeah, this should work. Z, Y, X. Map that whole thing over the forms to transform the forms into rotate V calls instead of rotate C calls, and that should do the trick. I hope. So now this rotate C is converted into rotate V calls, and it rotates 45 on X, which is what we see here. So I'm just doing this the brute force kind of way, where it'll just will it work though? Let me just double check something here. Rotate 0. Yeah. So here, actually, what I could do is the rotate function in the model gonna call that good enough for now. I'm thinking about efficiency things, and I'll just get to that stuff later. So using that approach, A is not what I'm testing. B is not what I'm testing. C and D are now different things. So if I, well, let's just do print line, write FCS of C. This should work for me. What? What happened? I don't know what I just, something went weird. Where is this coming from? What? Oh. No. Uh, I am confused. This square here, I don't know where it comes from, unfortunately. Let's see. I think I might have a problem with, I might have shadowed a name. I'm genuinely really confused here. I want to see what this translate does. Okay, so is so bizarre to me. Honestly, just don't understand. I'll get to the bottom of it, but how? 'Tis my question. Okay, so this part up to here is all sensible. This rotate 0 makes sense to me. This rotate 0 makes sense to me. This rotate 45 makes sense. We've got 1, 2, 3 rotates already. This fourth rotate is wrong, so there's something here. What is happening? Oh. Okay, well this is wrong here. So what this actually needs to be right, this is actually supposed to just be this should just be map right expression think that's correct. I was doubling things up there and using the wrong... Excuse me, using the wrong forms of functions there. So let's just check that this makes sense. It's a cylinder translated to its center. Then I translate it out of there. Then I rotate it 0 about Z, 0 about Y, and then 45 about X. So using that, that should now work better. Oops. Let's do this. Print line, write FCS of C. Yes. There it is. Okay. That's good news. Because C was defined with the... Now I can rotate with either of the two things. So the last thing I do want to just double check here is def C. Let's do that. I just want to see that it is rotating globally. And indeed it is. That's good. That's what I want to happen because it's equivalent to OpenSCAD. Excuse me, a little tired today. Okay, that's stepping in the right direction. So let's go ahead. I'll keep testing stuff later, but what I want to do is get some kind of difference operation in there. But actually, just before I do that, that's not what I meant to do. Huh. Oop. Right, sorry. I got distracted with what my mouse is actually doing. I don't like this mouse, but I haven't bothered to switch it in a while. I don't know why. Let's see. I'll be honest, I probably have to go soon because this stream is just not popping off for me. But before I give up on myself for the day, let's make difference, union, intersection, that sort of thing. We'll start with difference, which I know is the word cut in the FreeCAD scripting side of it. So let's get that sorted out. Oh yeah, that's right. The first thing I wanted to do was clean out some of this stuff that I'm not going to use. Right, so this, for example. And actually what I want to do is move this whole section. Let's do this. And this. There, rotation matrix. There. Okay, there we go. So we've got translate and rotate, simple. Let's do rotation matrix. Actually, we'll pop it like this. This is here as reference for if and when I do for if and when I improve how transforms are done. For instance, I could optimize output by baking all transforms down into a single matrix multiplication. Yeah. Okay, good. So that's transforms done. Let's peek in at this and delete old code here as well. Okay, so we got make sphere. Yes, just be happy with that. That's good, that's good. Get rid of this. And this. Just insist on doing things the more straightforward way. The more robust implementations I can do later on, if this is even if this is a worthwhile project to dig deeper into, then why not, right? But for now, we keep it simple. Simple's good. Simple is very good. I like simple. Okay. Booleans, difference, thank you very much. Let's get to it. Okay, so difference works on any number of forms. And it works by let's do it this way. We'll do this. Define cut forms. So we give it A and B. And the structure of this is, let's think about this. Right, so we have to do, let's do form A, form B. So what I do here is let A be right expression of form A. Likewise B, let's do it this way. A, B, map right expression over form A, form B. Now, I have no idea if this is going to work the way I think it is, but I digress. Let's give it a try. So what it should look like is basically string A Yeah. This kind of makes sense to me. So it's a string that to dot cut you close the cut with that, of course. And then it should maybe it should literally just be that, right? So then write expression for the difference. It's just gonna be this isn't quite right. It has to be well, I could do it like that. And then I don't need to do anything here. I can just literally do that, and that's way easier. Then the forms themselves become right. So the struggle I'm having is related to where I pull names from and how I format things. So that's why I'm contemplating. Right, so here what I've just done is named sketch circle as this thing, but then I translated it. But if I also if I wrap it in extrude linear height, now things have, so the sketch exists on its own, the extrude exists on its own as well. I think this might be the smarter way to do this sort of thing. So what I'll do instead, yeah, wait a minute though, because if I do this, it's only right by chance, right? Like, maybe this will work just fine. Let me think about this for a second. Well, okay, actually, so now what I want to do is, so with this right expression, I have effectively made a new shape. So I can't, if I get name of this, whole thing, it'll give me the wrong name, won't it? It gives me the first name, whereas it should do last, right? I think that makes more sense, and then using that I can fairly easily just do this, I think. So I let X forms be map right expression of forms, then I just reduce, if I reduce a list A, B, C, D, E with string, it does work. So this should maybe work. I don't think it will. We'll see what happens. Right, reduce with build cut X forms. What does that give me? Right, so if I def A as difference of cube 20, 20, 20 and cylinder radius 3, height 50. So it's a difference between these two objects. Now if I write expression of A, it That's not what I expected. Difference. Difference, props, forms. What? Let's try it. Let's have a look at this. Yeah, okay, so that has defined these two things, right? I am struggling. All right, what's going on here? First of all, if I give a thing two forms, it has two variable names and then the expression, which is fine. But that changes a little bit what I can do with this. So, wait a second, this isn't that hard at all, maybe. Maybe. Let's build it for the two form case and expand our thinking from there. So using this X forms, what I can actually do is string join string those forms onto the script. Then the names of each of those, right, get used. So it's like this. This should work a little bit like this. Should go like this instead. Yeah. I'm getting somewhere. Okay, so here, right, we've got let name be this gensim thing. Okay. Then you string together the result. Oops, I have to do, this is, name is that. So you string name equals get name of A with dot cut get name of B. That's the whole expression. That should work. So right, like it, so right expr of A. Yeah. So if I apply build cut to that, it's broken. Okay, get name works, so I'm not quite done here. So string together name gensim difference, yeah. Get name of, yeah, difference equals cube blah dot cut blah. Then using that, right, so can I do reduce with build cut right expr A? Yeah. So if I make a difference of cube 20 cylinder 350 and rotate 9000 cylinder 350. So now that's three things. So if I do reduce, I have to def this. Right, so A is now those three things. If I reduce right expression of A, doesn't work. Reduce that list with build cut. This difference is equal to the difference prior. Yeah. it almost works the way I need it to. So it doesn't quite, because I need it to so it'll work, right? Except for the issue where I need it to no, this could almost work. Okay, so I've got the list of forms. Right, so what I need to do here is not only string the name together, I need to string A, new line, string B, new line, return, so that cube is that whole thing. Oop. Typo. Print line. Ugh, messy. Okay, so you make the cube here. You make the cylinder here. You make your first difference cutting the cube and cylinder. You make the next cylinder, then you make your final difference, which is a difference between the existing difference and the cylinder here. Perfect. There you go. That looks like it'll work. And so doing that, I can actually now change this here to be this whole line, which is just, so right expression of A returns actually just X forms. So this whole thing ends up as reduce with build cut X forms. Okay. I think that'll work. So let's try it. Let's do, so we've got A is this difference operation. So let's print line, oops, write FCS, FreeCAD script of A. It just gives us all that Python. Let's put that into Good old-fashioned FreeCAD here. See if we can get it to work. Close. Well, in fact, it's not only close, it's exactly right. It's just small shapes, but it worked. That's exciting. Oh, I'm happy with that. Let's now do union, which I want to have be basically the same logic, but let's check 423 dot. There should be like a union operation or something like that. It might be called, I think, is it fuse? One second, let's do a equals part dot make cube 20 20 20 make box. Yeah, there we go. Okay, so we've got a box. Wow, very simple. So if I do a dot, we've got cut in there. Yeah, fuse, that's what it is. Okay, so fuse is the next thing to do. It should actually just be exactly the same logical approach, which makes this super easy. So let's do this. Paste all this in here. Build fuse. Union. Fuse. And reduce the list with build fuse. Xforms should work. Ooh. Oh, right, I have to do this, do this. Oh, this has to be fuse. And then this is difference. Yes. Okay, so let's get to def A. And we'll do def B is union. And I realize fuse is wrong here. It has to be union. B. Let's see what this looks like. Yes, perfect. It looks weird, but that is indeed the fusion of the parts that I had created, so it's looking good. Scale is quite off, but that is not something I'm going to worry about at the moment, to be honest. It's millimeter scale. I mean, it should be. I think it is. Let's do where's the measure tool? Measure. Where does it show me that? Measure, please. Oh, is it here? Sorry, I confused myself. Not quite sure. Oh. Close. Here to 0.787 inches. Yeah, okay, so it is millimeters is what the default numbers in here are millimeters, and then you get these measurements. Let's close this and get rid of, there we go. Clear console, boosh. Okay, so we got difference and fuse. Next thing is, oh yeah, I should check a dot. Is there there's got to be like an intersection calculation, right? Let's see. Let's check the bools. Intersection. Oops. Right. Part. Well, let's just do this the old-fashioned way. Matrix, memory, orientation, outer shell. Cleaned. Huh. Common. Oh, that's what I need. A dot common part dot make sphere 20 part dot show a. Oh, wait a second. Oh, I did this a little bit wrong. I actually want to do this. Part dot show this whole thing. Yeah. Yeah, there we go. That's super cool. Okay, so union and intersection should also be super easy. Paste this, build common intersection. Right, intersection, common, and then everything else should be the same. Let's see. Oops. Let's define C as intersection of those things. Oop. Come on. There we go. Took too long. Copy that. There it is. Oh, that's so good. Okay, so what's the next set of things to build into this? Right. Okay, so we've got boilerplate's fine. 2D, 3D. Oh, circle, we can get rid of this. We've got circle. We've got line, segment, and polygon. those might be useful. Square. Okay, circle, polygon, square. Open SCAD cheat sheet. .3D sphere, cube, cylinder, poly, extrude linear, extrude rotate. The thing to try would be something crazy like this. If I do let's try this heatsink deal. Call, oh, that's right, I made a color utility thing here. Okay, so heatsink, it doesn't matter much. This is also maybe still not a great test, but let's try this. Okay, so it generates code just fine. Let's write, oh sorry, let's uh-oh. Okay, so there's still stuff going wrong. Let's see here. What? Oh, color has to be ignored. Well, so let's take color out of the equation then. So let's I shouldn't ignore color. Is there a color option here? Let's do set colors. Ugh, gross. A dot style. Faces 0 dot b equals a dot faces 0. B is a face. B dot cut holes in a face. Oh. Oh, where are the attributes? Like color and things like that. color, please. Let's see, maybe there's some data here. Although, before I get into that, let me get rid of the color call altogether. Just to get rid of that as a variable here for a minute. If I write FCS of ASDF, ooh, it worked. Let's see if it generates the right shape, and we'll go from there. Right, so print line, write FCS ASDF. Let's see if this works. It didn't. It kinda did, but it definitely didn't. So it didn't union everything properly. So it's almost working. It's making all of the right cubes and stuff, but it's not unioning everything in the appropriate way, which is not good. Why is that? Let's see. Just sanity check myself here. So print line, write expression, ASDF. Whole bunch of cubes. We're close. We're getting close to the right operation, but we're not quite there yet. Oop. Right? Like, why is there only a single union here? So the reduce isn't actually working the way I thought it was. It ends up just taking the last does this? A is right expression of ASDF. There we go. We've got a list of cubes basically. Oh no, it's only one. Oh, hold the phone here. What am I doing? Yeah, okay. Cat. There we go. Now we've got a bit of something here. Then this maybe reduce instead of reductions, because that'll be confusing. There we go. There's a bunch of stuff there. There's got to be more than one union now, right? Yeah, looks like it. Okay, so let's just make sure that that's propagated. So there's the fuse. Intersection will need the same thing here. Like that. Union, just did it. Difference, need it here. Hopefully that works. Let's try. Let's try it one more time here, and then I'm gonna go source FreeCAD CLJ CS. Yeah. Good, good. A is this thing. Okay. ASDF. Yes, that's what I wanted. So write FCS, print line, write FCS ASDF. Come on. My typing is atrocious right now. All right, there we go. Okay. We're getting better. Getting better. So I have to look at how things nest in there, but we're getting closer to the right stuff. I can tell my translates don't propagate the same way or they aren't propagating the way I expect them to. So I have to fix that. But that's going to be a problem for another day. I'm going to get going now. If you're watching this on YouTube or anything like that, consider a like, comment, subscription, sharing my work around, that sort of thing. That's all I got to say. I should be back on Thursday, and I will be off on Friday. So if you want to catch the stream live, catch it on Thursday. Anyway, have a good one. Bye.